Hello, welcome back. So we're going to talk today about power series. So this is 8.5 and we're going to lead into 8.6. But 8.5, and this is power series. Okay, and so a power series is just a series of x. So actually you could consider them as functions, and we do. Okay, so it's f of x. We're not going to really talk about it as a function just yet, but the sum from n goes to 0 to infinity, c sub n, x minus a raised to the power n. Okay? So the c sub n are called coefficients. Okay? And if you have an infinite power, actually any power series, you have basically one of three options. And this is actually a theorem. Can't remember the name, but it is in the book. Okay, so there are three possibilities. Okay, first, okay, the series converges only at x equals a. All right. The second possibility is that the series converges for all x. And then the third possibility is that there exists some r okay, so that the series converges for x minus a being less than r, and it diverges if x minus a is bigger than r. Okay, now this doesn't say anything about x minus a equaling r. Okay, and we'll come to some situations where we have to do special things when x minus a equals r. Okay, so let's take a look at an example of all three. So let's take a look at one that never converges, only at x equals a. Okay, and actually it's funny, this one's related to the second example as well. So let's take a look at the sum. N goes from 0 to infinity, n factorial x to the n. Okay, so the sum n factorial x to the n, this is actually going to, let's take a look and look at it via the ratio test. Okay, so we're going to say a sub n is n factorial x to the n, and we're going to use the ratio test. Okay, so when we use the ratio test, that means we're taking the limit as n goes to infinity, the absolute value of a sub n plus 1 over a sub n. Okay, so this equals the limit n goes to infinity. Now a sub n plus 1 is going to be n plus 1 factorial x to the n plus 1 a sub n is n factorial x to the n. Okay, so this is going to be the limit as n goes to infinity, n plus 1, absolute value of x. So what happens to this as n goes to infinity? Well, if x is just any finite number, remember x is now, x is fixed. X is fixed now, okay? So that means eventually this is going to go to infinity, okay? Even if x is really, really small, okay, eventually that's going to go to infinity. Okay. All right. That was our first example. This is an example of a series that converges only at x equals a. So if x yeah. So here our a is 0. I should have written that down somewhere. Okay. Now, if x equals 0, okay, then this is just going to be 0. So I should really, if I'm doing this right, I should write that this limit equals infinity if x is not equal to 0, and of course it equals 0 if x equals 0. Okay. All right. Let's go ahead to the second example, which is almost the exact same thing. We're going to take a look at the sum. N goes from 0 to infinity, 1 over n factorial x to the n. Now, not for nothing, but I'm just going to go ahead. We don't know this yet, but I know it, so I'm going to tell you. This is actually a representation for the exponential e to the x. Okay, we don't know that yet, and I haven't taught you that yet, but we will learn that later on. Okay, so I just want to put that in your mind. Okay, so since it is a representation of something, leads us to believe that, hey, this should converge everywhere. Okay, so let's see. Let's take a sub n equals now 1 over n factorial x to the n. We're going to take the limit as n goes to infinity, absolute value a sub n plus 1 over a sub n. Now here, it's going to be sort of the same thing, but this n plus 1 is going to be on the denominator. Okay, so it's almost the exact same analysis, but we're going to get absolute value of x over n plus 1. And I should put limit as n goes to infinity. Now again, x is some fixed number now. Okay, we do it at some x. So no matter what x is, once we take the limit as n goes to infinity, we're going to 0. Okay, so what I mean by that is, as I'm taking this limit, we consider x fixed. Okay. All right. We'll do the one in between in the next video since I'm running out of page.